All right, so this is section 10.2, arithmetic sequences. Okay, so an arithmetic sequence is very similar to what we were talking about in section 10.1, right? It is just a1 all the way up to an, where k and n are just integers. If there exists a common difference d, such that ak plus 1 minus ak equals d, meaning the 1 in the term before it have this common difference d, right? Then the sequence is an arithmetic sequence. So let's look at some examples here. Notice, right, that between 2 and 5, that's a difference of 3. 5 and 8, that's a difference of 3. 8 and 11, difference of 3. So the difference here would be common 3. Now here, this one's a little bit more difficult because they have different denominators. So rewrite them all as the same common denominator, which would be 6, right? So 1/2 is 3/6, 5/6, doesn't need to change. 4/3 is 8/6, and then 7/6. So, is there a common difference here? That's what we need to think about, right? Okay, well, here is 2/6, right? Then here is 3/6. Then here is -1/6. There's nothing common here. This is not an arithmetic sequence then. It's a sequence, but not an arithmetic sequence, okay? All right, now, the nth term of an arithmetic sequence. So the nth term is just saying, okay, find a specific one, right? We just want to find out the 50th term, maybe, right? We don't really want to find that one because it would be a big number maybe, but we could do it. So what you need to know is the first term, the term you're trying to find, and the common difference, okay? So this is set up specifically knowing the first term. So now, there is a way to not know the first term because n is really just k plus n minus k, right? The k's would cancel, so n equals n. So really then we can set this up to be like this, where we know a different term, just ak. So then this is what we did here, right? So n minus 1, we just rewrote it such that we had k here instead to be this, all right? So now that will come into effect later on. All right, so now find the 51st term of the sequence. First, we need to figure out a few things. So the first thing is a1 is equal to 4, right? That's that first term. Okay, second thing to think about is the common difference. So the common difference here, 4 to 10 is 6, 10 to 16 is 6, 16 to 22 is 6, so common difference is 6. Always check it a couple times at least to make sure that it stays consistent. All right, so now we set up our kind of formula. An is equal to a1, so 4 plus n minus 1 times d, which is 6. Okay, so then we could simplify this if we wanted, or just leave it alone. I'd probably just leave it alone. So then we want the 51st term. So 4 plus 51 minus 1 times 6. So a51 is equal to 4 plus 50 times 6, right, which is 4 plus 300. So a51 is equal to 304. And that's it. Next example is they're giving us two terms and then wanting us to find a of 71. So this one's a little different, right? First we want to find d and then maybe find a1, right? and then we can set up the normal equation. So, how do we do this? Well, we've had a setup, right, for a n where we didn't know the first term, where a k plus n, instead of n minus 1, it's now n minus k times d, right? Well, we know a3 and a38, so let's use that. a38 equals a3 plus, well, 38 minus 3, and then d. So that means we have negative 312 is equal to negative 32 plus 38 minus 3 is 35d. So then add the 32 over, right? So let's see here. We have negative 312 plus 32. That would be negative 280 is equal to 35d. So then d is equal to, divide by negative 35, that's negative 8, right? Okay, so there's our d. Now we could find a1. So an is equal to a1 plus n minus 1, d is negative 8. So let's use an an that we know. Let's use a small one. Let's use a 3. So then this is a 3 as well. So a3 is negative 32 is equal to a1 plus 3 minus 1 is 2 times negative 8. So the negative 32 is equal to a1 minus 16. So add the 16. So a1 is equal to negative 16, right? So now we can set up our actual formula. A71 is equal to a1, which is negative 16, plus then 71 minus 1 times d, which is negative 8. So then we get negative 16 plus, well, 70 times negative 8. So 70 times negative 8, oh, that's technically a not a plus, a minus. So 70 times negative 8 is negative 560. So then A71 is equal to negative 576. And that's our answer there, okay? Now, we could have done it a slightly different way. We could have said, okay, stop here, we know D, right? Well, then A of 71 is equal to, maybe use A3 or A38. Let's use A38 plus n minus k, well, that's 71 minus 38 times negative 8, right? So then A71 is equal to, let's see, 38 is negative 312 plus, now 71 minus 38 is 33 times negative 8. So that's negative 312 minus 264 is equal to negative 576. We got the same number, okay? So you don't have to find A1. That's not needed unless you need to write out that original equation as well, okay? You just must know D. You have to know the common difference. Okay, so now, next example is write an explicit formula for the nth term. Okay, remember, explicit means using n, not using something from before, right? Okay, so common difference first. Here, 14 to 11 is negative 3, 11 to 8 is negative 3, 8 to 5 is negative 3, so we're good there. So we know A1 is equal to 14. We know then that D is equal to negative 3. So then AN is equal to 14 plus N minus 1 times D, which is negative 3. There we go. That's it. That's all we needed to do. Now, the nth partial sum of an arithmetic sequence. So, given an arithmetic sequence with first term A1, the nth partial sum is given by, so it's kind of like you're taking the average of the first term and the last term, so divide by 2, right? It's the average, and you're multiplying by how many of them you had, right? So it's really kind of cool with arithmetic sequences, the first and last term, and then the second and second to last term, they all kind of make that same combination, right? Because the differences are all the same. So what you add to get the second, you took away to get the one previous to the last. So it's pretty cool. All right, so an example here. Now, sigma is just a symbol that we use to say sum, find the sum, all right? So first here, if we're told we have 6 plus 4 plus 2 all the way up to plus negative 276. All right, let's think about that sum formula. We had n times the first term, so a1, plus the last term of an over 2, right? So n, how many do we have there? That's something we should figure out, right? So how do we do that? Well, we know that the first term is 6. Well, let's think about this. an is equal to the first term, so 6 plus n minus 1 times d. Well, let's figure out what d is. 6 to 4, that's negative 2. 4 to 2 is negative 2. So let's say, obviously, then that d is negative 2. We know what an is as well. It's negative 276. So negative 276 equals 6 plus n minus 1 times negative 2. So subtract the 6. Negative 276 minus 6 is negative 282 is equal to n minus 1 times negative 2. So divide by negative 2. So then n minus 1 is equal to positive 141. Add the 1 over, so n is equal to 142. Okay, so now we know what n is. So now we can set up 142 times a1, which is 6, plus an, which is negative 276 over 2. So then we have 142 times 6 plus negative 276 is negative 270. Divided by 2 is 135. So then multiply those together, right? So we have 135 times 142, and we get that the partial sum, or the sum of the first n terms of this sequence, is 19,170. I wouldn't put a comma here just because then, right, Alex thinks it's 2 answers sometimes. Okay, now how to read this sum notation. This is the setup of the sequence. That's how we kind of can find them, right? Just using J instead of N. Okay, so that means that J goes from 1 to 121. So we need to find those first terms. So AN, or A1, would be plugging in 1, right? So that's negative 4 times 1 is negative 4, plus 5 is positive 1. Then AN, where n is 121, is negative 4 times 121 plus 5. That's negative 484 plus 5 is negative 479. So now we can set this up. This is equal to 121 for n, and a1 is, what did we say, is positive 1, plus an is negative 479 over 2. Let's continue this down here. So then we get it equal to 121 times 1 plus negative 479 is negative 478 over 2. And 121 times, that's negative 239. So then 121 times negative 239 is negative 28919. Okay? So that's how we do these. A lot of times we have to figure out little bits and pieces here and there, right? Up here we had to figure out what n was. Down here we had to figure out what a1 and an was. All right, so then next example is we want to write a recursive formula for each sequence. Now remember, recursive means about using the previous terms, okay? So let's see here. A1. A1 is just that first term. It's 10, right? So then let's think about the common difference. So D for the first is what? What are we doing there? We are, well, we don't have to think about it that way. We could just say we know what A1 is, we know what A2 is, so then we know what A3 is, and so on, right? So when it says for n is greater than or equal to 2, that means we're just going to use the previous term. We're not going to use the previous two terms or something. So that means we can say A2 is equal to something with A1, right? Maybe some number times it. So let's say x times A1 plus B. I don't know. I'm just using random letters, right? So then A2 is negative 30 is equal to x times an is 10, so 10x plus b. Well, then we can set it up also for A3 is equal to x times the previous one, so A2 plus b. So then A3 would be 90 is equal to A2 is negative 30x plus b. Well, now we have this equation and we have this equation. So we can set that up. We can get rid of b right away, right? By just subtracting. So if we take 90 is equal to negative 30x plus b, multiply this whole equation by negative, so we get 30 is equal to negative 10x minus b, and add them together. So 90 and 30 is 120 is equal to negative 30x, and negative 10x is negative 40x. B and minus b is 0b. So then x would be equal to negative 3. Okay, so now we can figure out what b is, or if b is equal to anything. So negative 30 equals 10 times negative 3 plus b. Well, that's negative 30 equals negative 30 plus b, so b is 0. So that means we can write an as negative 3 times an minus 1. Let's check it on A4. So A4 is equal to negative 3 times A3. So we're saying negative 270 is equal to negative 3 times 90. Well, 9 times 3 is 27, so that's negative 270. So it worked. Okay, so this is our formula for that first one. Okay, so now we can do the same kind of thing for this second question. So a 1 is 16. So then we can write out a 2 is equal to x times a 1 plus b. So then we have 27 is equal to 16x plus b. Then we can write out a 3 is equal to x times a 2 plus b. So that would be 38 is equal to 27x plus b. So again, we can multiply one of them by a negative. So let's multiply this one by a negative 1. So we have negative 27 is equal to negative 16x minus b. Add together, that's, what is that, 11 is equal to 11x plus, no b. B went away, right? 0b. So then x is equal to 1 for this one. Let me just break these off. So we have x is equal to 1. We can find b then. So then b, let's plug it into the first one. We have 27 is equal to 16 times 1 is 16 plus b. So b is equal to 11 here. Okay, so now this setup would be a(n) is equal to a(n) minus 1, because x is 1, plus 11. We can check it really quick to just say a4 is equal to a3 plus 11, so that's 49 is equal to 38 plus 11. That is true, so that works. Okay, so that's how to write out a recursive formula if you're given multiple terms. Okay, and that is also the end of the 10.2 lecture.